Steaming along, water, freezing and melting. STEAM stands for science, technology, engineering, art, and math. When we learn in a STEAM framework, it's about asking questions, problem solving, experimentation, finding answers, and then asking more questions. It's a great way for all of us to learn. Today, we're going to talk about water. Water exists in three states. So we talk about liquid water, like a glass of water. Water can also be a solid when it's an ice cube. Water can also be a gas, steam when it's coming out of the tea kettle as it boils on the stove. Water exists in all those ways. Let's start with the liquid. Here I have my water in my measuring cup. As a liquid, water takes the shape of the container that it's in. So right now, my water is measuring cup shaped. What happens if I pour it into a different container? Will it stay measuring cup shaped? Here's my glass. My water took the shape of the container that it's in now, a glass. Let me try one more time. Here's my bowl. I'll let you see that it's kind of a square-shaped bowl on top. What do you think will happen? My water, because it's a liquid, took the shape of the bowl that it's in now. Water freezes when it reaches 32 degrees Fahrenheit. So the water turns to a solid, my liquid water turns to a solid when it reaches 32 degrees. It crystallizes and the molecules separate as the water turns to ice. Because they're separate and farther apart, ice is lighter than water. So if you ever put ice in a cold drink, it floats to the top. We said that water takes the shape of the container that it's in. When I want to make ice in my freezer, I use an ice cube tray. This one has ice cubes in it, but you can see all those small compartments for me to pour the water in. When I pour the water in, it will be those shapes, each of those. After I put it in the freezer and the water has time to go below 32 degrees, turns into ice cubes. This is my tray of ice cubes. Let's see, a little shiny. Crack my tray, bend it a little bit, and take out my ice cubes. I made these out of water, but these are solid now. When water becomes ice, it becomes solid. What do you think will happen if I put this ice cube into this same square bowl? Will it take the shape of the bowl like the water did? So ice will stay the shape when it's a solid of the container that it was in when it went from a liquid to a solid, when it froze. Put these down for a minute. When I take the ice out of the freezer, it's coming from 32 degrees, cold enough to freeze it, out into, I'm going to say about 70 degrees here in my office. If it was 32 degrees here, I'd have a scarf on and a hat and a coat. But the air in my office is warmer than the freezer where this ice was. So pretty soon, what do you think is going to happen as this cold ice is in this warm office? The warm air will surround it. My ice cube will start to melt from the outside to the inside. Will start to turn back into water. We see this happen when we put ice cubes into a drink. Our drink isn't frozen, the liquid we pour into our glass. The ice will rise to the top, but if we put our drink down for a few minutes and come back to it, the ice cubes are smaller. If we put it down for a while and come back, the ice cubes might even be gone. Our drink might even taste a little bit watery because all of those ice cubes have turned back into water. Let me pour some of our water with the ice cube. Now my ice cube is surrounded by water that's warmer. I don't know how long it'll take to melt. I wonder if it'll melt quicker if I stir it. Will that make my ice cube get smaller, faster? This is room temperature water. It's not very hot and it's not very cold. I wonder what would happen if I poured a mug full of hot chocolate and I put ice cubes in it to cool it down. Do you think those ice cubes would melt quickly? Just from stirring, my ice cube got pretty small. This is how big it was to start. I'm going to look again at the ice cubes in my bowl. I just put them there to sit. They're starting to drip. There's a drip. They're starting to drip water as they start to melt in the warm air. You can also make ice cubes in other containers. And try making a bigger ice cube, maybe in a yogurt container. Fill it with water and put it in the freezer. Will it take longer to freeze if it's bigger? Will it take longer to melt? How can we make ice melt quicker? I know that if I hold this in my warm hand, it will drip, drip, drip all over me. At the Somerset County Libraries, we have a number of resources on any science, technology, engineering, art, and math topic that you're interested in. I just pulled a few on water. Changing states of water, life and times of a drop of water, and water is water. All of our libraries also have a number of books that have different experiments and routes for exploration. Simple everyday science, melting, freezing, and boiling, and STEAM Lab, a variety of activities to explore. On our website, sclsnj.org, in the Research and Learn Kids section, there's a database called Explora for primary grades. This is a database that has sections for science, technology, art, and math. And within each of those sections, there's a variety of subsections for all the topics that you want to explore. STEAM stands for science, technology, engineering, art, and mathematics. And when we learn in a STEAM framework, we ask questions, we explore, we experiment, we problem solve, and then we ask more questions. A great way for all of us to learn.